Imagine a quiet computer room late at night. No voices. No movement. Just rows of machines quietly processing information. Inside these machines, millions of calculations happen every second. Patterns are analyzed. Predictions are made. And slowly, something unusual begins to emerge. The machine begins to learn. This idea lies at the heart of artificial intelligence. Not magic. Not consciousness. But systems designed to recognize patterns in data. Tonight, we'll take a slow journey through the story of artificial intelligence. From early dreams of thinking machines to the powerful learning systems of today. Artificial intelligence is often described as machines performing tasks that normally require human intelligence. These tasks might include recognizing speech, understanding images, or generating language. But at its core, most artificial intelligence is about one thing: pattern recognition. An AI system studies examples, and over time, it begins to recognize relationships inside the data. In a way, it is similar to how humans learn. By observing patterns and gradually improving predictions. The idea of intelligent machines is older than modern computers. In the 1940s and 1950s, scientists began wondering whether machines could one day simulate human reasoning. One of the most influential thinkers was mathematician Alan Turing. He proposed a simple question: can machines think? To explore this idea, Turing designed a test. If a machine could carry on a conversation indistinguishable from a human, it might be considered intelligent. Early AI systems relied heavily on rules. Engineers attempted to write detailed instructions for every situation. But the real world turned out to be far too complex for simple rulebooks. So researchers began exploring a different idea. Instead of programming every rule, machines could learn patterns from data. This approach became known as machine learning. The more examples a system studied, the better it became at making predictions. One powerful approach to machine learning was inspired by the human brain. Researchers created simplified models called neural networks. These systems consist of many small processing units, often called artificial neurons. Each neuron receives signals, performs a small calculation, and passes information forward. When many layers of these neurons work together, complex patterns can emerge. Modern artificial intelligence relies heavily on data, images, text, audio recordings, and countless other forms of information. By studying enormous datasets, AI systems gradually learn statistical patterns. The more examples a system sees, the more accurate its predictions can become. One of the most visible forms of artificial intelligence today is something known as a language model. A language model is a system trained to understand patterns in human language. It studies enormous collections of written text and gradually learns how words tend to appear together. These collections of text can include books, articles, research papers, websites, and many other forms of writing. By studying these examples, the system begins to recognize the statistical structure of language. Which words follow other words? How sentences are typically formed, and how ideas are connected through language. Modern language models are often called large language models, or LLMs. The word large refers to both the size of the training data and the number of parameters inside the model. Parameters are the adjustable numerical values that allow a neural network to learn patterns. Some modern language models contain billions or even trillions of these parameters. To understand how these models work, it helps to look at how they process text. Instead of reading words directly, the model first breaks text into smaller units called tokens. A token might represent a word, a piece of a word, or sometimes a punctuation mark. The system then processes these tokens through many layers of a neural network. Each layer performs mathematical transformations, gradually refining the model's internal representation of the text. During training, the model repeatedly practices a very simple task. It tries to predict the next token in a sequence. For example, if the model reads the phrase, "The earth revolves around the," it might learn that the word sun is very likely to appear next. By repeating this prediction task billions of times across massive datasets, the model gradually develops an internal map of language patterns. When you interact with a language model, the process is surprisingly similar. The model receives a prompt. It analyzes the sequence of tokens and then predicts the most likely next token. That token is added to the sequence, and the prediction process repeats. Word by word, sentence by sentence, the response gradually forms. This process can create the impression of conversation or reasoning. But underneath, the system is performing an enormous number of probability calculations. In recent years, researchers have begun connecting language models to external tools. This approach is sometimes described as an agentic framework. In this setup, the language model does more than generate text. It can also decide when to call other systems. For example, an AI system might use tools to search the internet, access a database, write computer code, or control the software application. The language model acts as a kind of reasoning layer, interpreting the user's request and deciding which tools might help complete the task. In some systems, the model can even plan multi-step actions, breaking a complex task into smaller steps and executing those steps one by one. This is why the term agent is sometimes used. The system behaves like a digital assistant capable of interacting with its environment. Even so, the intelligence behind these systems still comes from the same foundation. Pattern recognition learned from enormous amounts of data. The result is a new kind of computing interface. One where humans communicate with machines through natural language. And as these systems continue to improve, the boundary between software tools and conversational assistants may gradually become less distinct. Many people interact with artificial intelligence every day. Navigation apps estimate traffic conditions. Streaming services recommend movies. Email systems filter spam. Often these systems work quietly in the background, invisible but constantly analyzing patterns. Despite their impressive abilities, artificial intelligence systems have clear limits. They do not possess consciousness. They do not experience emotions. Instead, they rely on statistical patterns learned from data. This means they can sometimes produce mistakes or generate information that appears convincing but is incorrect. As artificial intelligence continues to develop, researchers often ask a simple question: what kinds of problems might machines help us solve in the future? In many fields, AI is already beginning to assist scientists and engineers. In medicine, machine learning systems can analyze medical images. sometimes helping doctors detect patterns that are difficult for the human eye to see. Researchers are also using artificial intelligence to explore new medicines. By simulating how molecules interact with the human body. In climate science, AI models are helping researchers analyze enormous datasets collected from satellites and weather stations. This information can improve predictions about weather, ocean patterns, and long-term climate trends. Artificial intelligence is also becoming a useful tool in scientific discovery. Some systems can analyze huge collections of research papers, identifying connections between ideas that might otherwise take years for scientists to notice. In engineering, AI systems are helping design new materials, exploring millions of possible combinations to discover structures with unusual properties. In robotics, artificial intelligence may allow machines to navigate complex environments, helping them assist with tasks that are repetitive, dangerous, or physically demanding. But alongside these possibilities, many researchers emphasize the importance of careful design and oversight. Artificial intelligence systems are tools created by humans. And like any powerful tool, their impact depends on how they are used. Questions about privacy, fairness, transparency, and safety are now important areas of study. Across the world, scientists, engineers, and policymakers are working together to guide the responsible development of these technologies. Despite the complexity of modern AI systems, the core idea remains surprisingly simple. Machines are learning patterns from data and using those patterns to assist humans in understanding the world. The future of artificial intelligence will likely be shaped not only by technology, but also by human choices. How we guide these systems, how we apply them, and how we decide to use them to support knowledge, creativity, and discovery. And quietly, in research labs and data centers around the world, the learning continues. Millions of calculations each second. Patterns forming inside networks of mathematics. A new chapter in the long story of how humans build tools to better understand their world.